When astronomers first detected an unusual object entering our solar system from interstellar space, the announcement attracted little attention outside scientific circles. To researchers, it was exciting. To everyone else, it seemed like another distant astronomical event, interesting, but unlikely to change our understanding of the universe. After all, interstellar visitors are rare, but they are not impossible. Occasionally, gravity sends fragments of distant worlds wandering across the galaxy. Some may have been ejected from young planetary systems billions of years ago. Others may be remnants of ancient collisions, drifting through space without a home. Most travel silently through the darkness, never approaching a star closely enough to be noticed. This object appeared to be one of those travelers. Early calculations showed that it was moving too quickly to be permanently bound to the Sun. Its path indicated that it had arrived from beyond our solar system and would eventually leave again, continuing its journey into interstellar space. At first, that seemed to be the entire story. But science often becomes interesting when reality refuses to behave exactly as expected. As telescopes around the world focused on the object, researchers began collecting more detailed observations. They measured its brightness, tracked its motion, analyzed its composition, and monitored how it interacted with sunlight. Most of the data appeared ordinary. Yet a few details stood out. The object's brightness changed in ways that were difficult to predict. Its thermal characteristics suggested a more complex internal structure than some initial models anticipated. None of these observations violated the laws of physics. None suggested anything impossible. But they were unusual enough to keep scientists interested. Whenever researchers encounter something unexpected, their first assumption is not that they have discovered something extraordinary. Their first assumption is usually that they are missing part of the explanation. And so the investigation continued. Observatories on different continents compared measurements. New computer simulations were created. Alternative models were proposed. Every possibility was examined, from unusual mineral compositions to complex surface structures that could influence the way heat was absorbed and released. The more data accumulated, the more one fact became clear. This object represented an opportunity. Not because it was necessarily strange, but because it originated somewhere else. Every asteroid and comet within our solar system tells part of our local story. They reveal information about the formation of the Sun, the birth of planets, and the early history of Earth's neighborhood. An interstellar object is different. It carries information from another stellar environment entirely. Imagine picking up a bottle washed ashore from a distant continent. Even without a message inside, the bottle itself reveals something about where it came from. The material, the design, and the signs of where all provide clues. Interstellar visitors are similar. Their chemistry, structure, and behavior can offer hints about planetary systems that humanity may never directly observe. That possibility alone is remarkable. The object may have begun its journey around a star that no longer exists. It may have formed before Earth developed complex life. It may have traveled through regions of the galaxy that our species will never see firsthand. For millions or even billions of years, it drifted through the immense darkness between stars. That darkness is difficult to comprehend. The distances separating stellar systems are so vast that even light, traveling at nearly 300,000 kilometers per second, requires years to cross them. Human spacecraft, moving far more slowly, would need tens of thousands of years to complete the same journey. Yet this small object accomplished exactly that. It crossed the gulf between stars and arrived in our cosmic neighborhood carrying a history written into its atoms. As news of the discovery spread, public imagination quickly became involved. Whenever something mysterious appears in the sky, speculation follows. Some people wondered whether the object might contain evidence of unknown physics. Others imagined hidden structures or signs of artificial origins. Social media transformed ordinary scientific discussions into elaborate theories. Researchers, however, remained cautious. Extraordinary claims require extraordinary evidence. At the time, no observation suggested advanced technology. No signal had been detected. No behavior indicated intelligence or deliberate control. The object was mysterious, but mystery alone is not proof of anything unusual. Still, the fascination persisted. And perhaps that fascination reveals something important about human nature. For centuries, humanity has searched for evidence that life exists elsewhere in the universe. We have listened for radio signals, studied distant planets, and imagined countless scenarios for first contact. Yet when confronted with a genuinely unknown object, our minds immediately begin constructing stories. We search for intentions. We search for meaning. We search for evidence that we are connected to something larger than ourselves. The object became a mirror reflecting those hopes and questions back at us. In reality, the most extraordinary aspect of the discovery may not have been the object itself. It may have been what the object represented. For most of human history, the stars appeared isolated. Ancient civilizations saw them as fixed points decorating the night sky. Even after modern astronomy revealed their true nature, the vast distances between them made interstellar travel seem almost impossible. But objects like this remind us that the galaxy is not completely separated. Material moves between stars. Dust moves between stars. Molecules move between stars. Fragments of worlds move between stars. The Milky Way is not a collection of isolated systems. It is a dynamic environment where matter is constantly exchanged across immense distances. Every interstellar visitor is evidence of that connection. Each one carries information from another corner of the galaxy. Each one serves as a reminder that our solar system is not isolated from the larger cosmic story unfolding around it. As scientists continue studying these visitors, they hope to learn more about planetary formation, chemical evolution, and the diversity of environments that exist beyond our own stellar neighborhood. The answers may not be dramatic. The object may ultimately prove to be a perfectly natural fragment of rock and ice formed through ordinary processes. But that would not make it less remarkable. Nature itself is capable of producing wonders that often exceed our imagination. A piece of material traveling between stars for millions of years is extraordinary whether or not it contains anything unexpected. And perhaps that is the lesson these discoveries teach us. Wonder does not require certainty. The universe does not need alien messages, impossible technologies, or sensational revelations to inspire awe. Sometimes a silent traveler is enough. Sometimes a small object crossing the darkness between stars can remind us how vast the cosmos truly is. How little we know. And how many mysteries remain waiting beyond the limits of our current understanding. Long after this visitor departs and disappears back into interstellar space, the questions it inspired will remain. Where exactly did it come from? What history does it carry? How many similar objects are wandering unseen through the galaxy at this very moment? And if the universe is capable of sending such travelers across unimaginable distances, what other surprises might still be waiting among the stars? For now, we do not know. But every discovery like this brings humanity one step closer to understanding the larger story of the cosmos. A story still being written across the darkness between the stars.